All right, here we go with our first lesson in Calc BC. So we're going to be doing integration by parts. Before we start that topic, we do need to just recall a couple of the most important integrals that we'll see. So I put that little cheat sheet here for you. This is just copied from your textbook, so you could also use your textbook for that as well. Okay. We have not touched on very many different skills with integration. So just remember that every differentiation rule, like chain rule, product rule, quotient rule, has a corresponding integration rule, a way to undo that. So all we've learned so far is the substitution rule, which will undo the chain rule, okay? What we're going to learn today is the way to undo product rule. It's called integration by parts. Okay, so it's undoing product rule. So I'm going to give you kind of like the formal definition and where it comes from. So we're doing like a little mini proof here. You're not being tested on this. This is just to show you the why. So here's product rule. And remember, with product rule, we call this U and V. So this is U, V prime plus plus V, U prime, which we switch it around and call it U prime V plus UV prime because it has a better ring to it, but same thing. Now, if I want to undo this, I would need to integrate, right? I would need to integrate. So I'm going to put an integration symbol here, and I'm going to integrate the right side. And I should end up with f of x times g of x. I'm going to write it in a different way in terms of u and v. So this would be also the same as f is u, and g prime is v prime, or we could call it dv. So this would be the same as u dv plus g is v, and f prime would be du, so plus v du. And ideally that would equal u times v. So remember, all I'm doing is I'm changing this v prime into dv, which just means the derivative of v. So it's the same thing. Okay? I can keep going. And what I would do next is split up the integral so that there's an integral attached to each portion with a plus sign in between. Okay? And then the next thing I'm going to do is I'm going to rearrange this. So I'm going to subtract the integral v du on both sides. And here's what I end up with. The integral of u dv is equal to uv minus the integral of v du. That is actually the formula for integration by parts. And so the way that we will use this is we will start with this left side here that's called the integral of u dv, okay? So what you're going to be looking for are two things being multiplied together. One is going to appear to be something that's easy to derive, and something else is going to be easy to anti-derive. And I'll explain what I mean here in a second. But your original question is going to be something is going to be called u and something is going to be called dv. Once you identify what those two things are, then you will use the right side of the problem to sort of solve, okay? To break it into something that's easy to integrate. It's kind of hard to explain without an example, so let's just get to it. Real quick, this is something we're going to use. We're going to use this setup right here to help us set up every problem. So it's like a little box chart where we have u equals and du, so that kind of looks the same as like u substitution right here. But then we'll have this extra piece there for dv and v, okay? Here we go. So you will notice that this is not something I can use u substitution for because x and sine x, I can't derive one of them to get the other. You know what I mean? So this is going to be integration by parts. So because this is new, I'm going to write down the formula again. So the formula is, the thing we start with is u dv. And the formula we use to solve it is uv minus the integral of v du, which in the past we've called that voodoo to help us remember. So uv minus voodoo. Okay, so what I want to do is I want to set up my little chart. So u is something, dv is something, du, and v. Okay? I'm going to focus on the first two things. So I need to choose something for u, and I need to choose something for dv. I need to keep in mind that whatever I choose for u, I will be deriving that to get du. And whatever I choose for dv, I will be anti-deriving to get v. So I need to find something for u that would have a nice derivative, and something for dv that has a nice anti-derivative. I want to make things simple, okay? Simpler than what they are now. So I'm going to choose x to be u, and I'm going to choose sine x dx to be dv. Okay, so x, I'm going to say let's have u be x, and dv is going to be sine x dx. So let's find our two missing pieces. That way we can plug everything into our integration by parts formula. So du would be the derivative of x, which is 1. We call it 1 dx. And then for dv, I have to anti-derive to get v. Antiderivative of sine is negative cos. And I have everything I need now. So all I have to do is plug all of this information in my little chart. All this information, got to plug it in to my formula. So my formula is this part here that's under the squiggly line. So the antiderivative of x sine x is equal to u times v. So u is x and v is negative cos x, minus the antiderivative of voodoo, so v du. That's negative cos, I'll make this a plus, cos x dx. Okay, now what you've done is you've taken a problem that was insolvable and you've turned it into something that you can now solve. It's not done. What you have to do now is you need to simplify this first part, so make it negative x cos x, that's easy. But then you actually have to integrate. You got to integrate still for that second half. The goal is to get everything all the way broken down to antiderivatives. So what is the antiderivative of cos? That should be sine. Now that I've antiderived everything, I can put plus c and I'm done. Let's try another one. Okay, this one's a little deceiving. I'm going to write my formula down again. All right, here's my formula. So my goal is I need to set this up so that I have something in place of u and something in place of dv. So from what I've got up here, I think the only thing that works is to make ln x my u, because the derivative of ln is 1 over x, so something simple. And then I'll just use dx, or 1 dx, as my dv. And then I'm going to derive u, so the derivative of u is 1 over x dx. And the antiderivative of dv, it would be, since it's a constant, it would be 1x, or you can just put x. Now I'm going to plug this into my formula, okay, my integration by parts formula. So We are anti-deriving ln x. And the formula says take u and times by v. So that would be x ln x. Subtract the antiderivative of voodoo. So v du. So that would be x times 1 over x dx. Okay, that worked out super nicely because I can algebraically simplify. X times 1 over x is just 1. And remember, you still have to antiderive this part. So you still have to go one more step. Antiderivative of 1 would be 1x plus c, and you're done. Okay, let me show you where this can get a little bit tricky. So I have 2 more examples for you. On this example, we are going to run into a little bit of an issue. Here's our formula. Okay, so when we start this, we normally set it up where we're trying to find something for u and something for dv. And keep in mind, u needs to be something that's easy to integrate, not just easy, something that gets simpler when it integrates. And dv needs to be something that's easy, or sorry, when it derives. And dv needs to be something that's easy to integrate. So I'm going to set this up as t squared for u and e to the t dt for dv. So du is going to be 2t dt, and v is going to be e to the t. Okay. Let's plug all this stuff into our integration by parts formula and see what happens. So u times v would be t squared e to the t minus the antiderivative of voodoo, which would be, if I rearrange a little bit, 2t e to the t dt. Now, normally what we would do is we would go through and we would try to integrate right here. But we can't because we still have 2t times e to the t, which means a product of 2 things. So we still have to find another way to separate that. Substitution won't work because it's a product of 2 things that aren't related whatsoever. So the only way to undo that is integration by parts again. Okay, you got to do it again. So you're going to set it up where I'm going to use integration by parts, but only for this integral here at the end. So this 2t squared e to the t, that's going to stay exactly where it's at. That's going to stay exactly where it's at, and I'm going to use integration by parts for this integral that I just created. So I'm going to go over here to the right, and I'm going to say, I'm going to have u be 2t, and dv is going to be e to the t dt. So kind of like last time. But this time it's going to help, it's going to be better because the derivative of 2t is just a number now, which is going to make our lives easier when we go to plug it back in. So I'm setting up this little chart to help do integration by parts for this integral. So now I'm going to do my integration by parts. So that would be, what was it, uv, so 2t e to the t minus, but that becomes a plus because there's a subtraction sign right here. Voodoo, so that would be 2e to the t dt. Now I can go further and I can integrate this last part because it's just a constant with the e to the t, it's just 2 in front, so that's something that I can integrate now. So it would be plus antiderivative of e to the t is e to the t. So I just need a plus c and I am done. Okay, let's do that again because that can get a little bit confusing or a bit confusing. Let's do that again and see what happens. So actually I think I'm going to skip this one. We'll come back to this one during class. Here we go. So this one's going to have a little bit of a twist to it as well. Not exactly the same as the last example, but similar. All right. So I've got inverse tan x dx. I can't do this without integration by parts because I have no idea what function has a derivative that equals inverse tan. That's not on our chart. It's not a cheat sheet thing. So we have to do integration by parts. We're going to say u is going to be inverse tan, and dv can be dx. And du, remember inverse tan, I think it's that 1 plus 1 over x squared equation. V would just be x. Antiderivative of dv is x. Okay. Let's plug this in and see what happens. So we get inverse tan x dx. We're evaluating from 0 to 1. Use integration by parts. So our formula says uv x times inverse tan x minus the antiderivative, and this is from 0 to 1, of v du. So that would be x over 1 plus x squared. Okay. At first glance, it would appear we just made the problem more complicated. It does look like that, but I can assure you that it's not more complicated. Here's why. Oh, I forgot something. I got to evaluate this from 0 to 1. This integral that I have on the right side, it is quite complicated, but we can actually solve that using u substitution. I think we saw this in our circuit. Pretty sure we had this exact problem in our circuit, but not evaluated. So I can make u the denominator, and I can derive that and get 2x dx. And then I'm going to move the 2 over because I don't need that. So it would be 1/2 du is equal to x dx. Okay. Let's see what we can do here. Okay, so if I do u substitution, I would have 1/2 times 1 over u du. Does that sound right? 1/2, I think I want to move that outside the integral. 1/2 1 over u du is where I'm at right now. And then then I'm going to antiderive, which antiderivative would be ln. And I'm evaluating that from 0 to 1. I think I'm going to use the shortcut where I change the 0 and 1 in terms of u, so I don't have to change everything back to x's. So if I do that, I'm going to plug 1 into my u equation. So that's 2. So this will become a 2. And plug 0 in, and you get 1. So this will become a 1. And now I'm going to do a whole bunch of plugging and evaluating. So I'm going to have, over here, I still have to evaluate this first thing. That was my UV. I have to plug 1 and 0 into that as well. So it would be 1 times inverse tan of 1 minus 0, because I would plug in 0 for x, and that would eliminate that whole thing. And then over here, I have 1/2 ln of 2 plus, because of the double negative, 1/2 ln of 1. I don't know why I'm putting these in absolute values when they're positive numbers. Okay? And then we're just going to evaluate as much as we can, just not a whole lot. So over here, inverse tan of 1 means when is tangent 1? That is pi by 4. 1/2 ln of 2, And 1/2 ln of 1, remember ln of 1 is 0. So this whole thing is gone. And I'm going to do one more step to remind you of some ln rules we haven't seen in forever. Remember, when you have a number in front of a ln, it technically could be applied as a power. So I could write this as ln of 2 to the 1/2 power. And one more step, I could say, if I wanted to be really extra thorough, I could say 1/2 power is the same as square root. So pi by 4 minus ln radical 2.